Good morning, dear students. Today we are going to study about next chapter, that is your stereochemistry. Stereochemistry, it is made of two words, stereo plus chemistry. You know the definition of chemistry very well, and I think stereo is word is different, new for you people. Stereo means three dimensions. Three dimensions here, stereochemistry overall, it means three dimensional study of molecules. Three dimensional study of the molecules. Whenever you feel allergic or some cold is there, you move towards your doctor. He recommends you citrazine. He recommends normally citrazine in the old days. But nowadays, if you go to the doctor, he recommends you levocitrazine. So, question arises why nowadays instead in place of citrazine, levocitrazine it is recommended. The citrazine, it contains two isomers. One is the levocitrazine and another is the dextrocitrazine. The levocitrazine it is anti-allergic, while dextrocitrazine is sleep inducing. Doctor recommend you, if you take the citrazine you cannot drive, but if you take the levocitrazine you can drive, because we have isolated the second component from the citrazine, that is dextrocitrazine, and you have only levocitrazine, which is anti-allergic medicine. So this is the importance of stereochemistry. With the help of a study of the stereochemistry, we can isolate two different isomers which seems to be same to you. We can isolate with the help of stereochemistry those isomers. One isomer has beneficial effect and another isomers have non-beneficial or harmful effects. So we need to separate those compounds. So in this chapter we will study about what are the stereoisomers, what are the optical isomers, what is the chirality, what do you mean by asymmetric carbon, what are the symmetry elements, how you can distinguish the optical isomers with the help of RS configuration, what are the diastereomers, how you can represent the structures with the help of Fisher's projections, and what are the conformational isomers. So let us discuss about what are the isomers. We have must study about the isomers. Yes, let's study about the isomers. Isomers means the compounds which have same molecular formula but different structure. Simply, isomers means the compounds which have same molecular formula but different structure. So I already told you stereochemistry means the study of molecules in three dimensions. Let us take the simple example of organic molecule. Simple molecule example is methane. Generally we represent the methane with this formula. So this is the formula of methane. If you have to represent its structure, you should sometimes people write like this. This is the methane, and this is the representation of methane on two dimensions. But I have told you that stereochemistry means representation of the molecules in a three dimensions. So how this molecules it can be represented in three dimensions? Let's see. First of all, you have to see what is the hybridization in this case. This hybridization you have studied in previous classes. The hybridization of carbon, in this case it is sp3. sp3 hybridization means how many orbitals are involved? One s orbital is involved and 3 p orbitals are involved in this case. According to molecular orbital theory, 4 orbitals are involved in this case. It means around the carbon 4 orbitals are there. According to molecular orbital theory, these orbitals must be maximum apart from each other. These must be maximum apart from each other. How these can be made maximum apart in these can remain maximum apart from each other? Can they remain like this? Carbon is at the center and hydrogen are in plane. This is not the maximum apartness of the hydrogen from the carbon. But in case of certain inorganic compounds, such a configuration also exists. In the case of methane, here you can see that 4 hydrogens are there. You can compare this methane as your fan. In the case of fan, there are 3 wings and one is the vertical rod. At the center, there is a circular material, and this circular material is carbon, and one methane is towards the upward, just like the fan rod, and the rest 3 hydrogens, these are the wings. So you have to make them maximum apart from each other. If you have to make them maximum apart from each other, you have to bend the wings, 3 wings of the fan at the angle of 109.4 degrees. Then all the bonds will become at equal distance. So how you can represent this structure? Here what you have to do, first you have to keep 2 hydrogen in the plane as this appears. You have to keep the 2 hydrogen in and carbon in one plane as it appear on the smart board, and we are left with 2 hydrogen. One hydrogen it is projected towards you. One hydrogen it is projected towards you. It is represented with the help of dark wedge. And another hydrogen it is away from you. It is represented with the help of dashed wedge. It is represented with the help of a dashed wedge. Let us see. This is the tetrahedral geometry, and here at the center black, one is your carbon, and these 2 poles, these are the 2 white balls, these are your hydrogens, and these hydrogens lie like this in the plane. These are in the plane. In one hydrogen black pen, it is away from you, and this another pointer, black pointer, it is towards you. Towards you, it is represented with the dark wedge. Towards you, hydrogen it is represented with the dark wedge. While away from you, it is represented with the help of dashed wedge. So in this way, you can represent the methane in 3 dimensions. So there is no question about the methane only in this case. There are many molecules which are optically active and many molecules which are optically inactive. So isomers means having same structure, having same molecular formula but different structure. So first of all, let's discuss about the classification of the isomers. I have told you what you mean by the isomers. Isomers means same molecular formula but different structure. If there is not same molecular formula, then those are not isomers. After isomers, you have to classify. You have to find out whether the connectivity is the same, whether the connectivity between the atoms is same or it is different. If connectivity between the atom it is same, then those isomers are known as stereoisomers. Then those isomers are known as stereoisomers. If the connectivity is different, then those isomers are known as constitutional isomers, or these are also known as structural isomers. Let us see. These structural isomers or constitutional isomers can be further divided into chain isomers, position isomers, functional isomers, metamers, tautomers, and ring chain isomers. So I have told you isomer simply means having same molecular formula but different structure. Let us take the example. If I write butane, butane means butane is having how many carbon? 4 carbon. Complete the valency. This is the butane. This can be, you can write same molecular formula structure like this: CH3, CH, CH3, CH3. So are these two structures are same? Definitely these are not the same. This is a linear molecule, this seems to be branched molecule. Let us see the molecular formula of the first linear structure, that is the N-butane. In the case of N-butane, how many carbons are there? 4 carbons are there. How many hydrogens are there? 3, 4, 5, 6, 7, H10. And in second case, how many carbons are there? 4 carbons are there. How many hydrogens are there? 3, 3, 3, 9 and 10. So in these both cases, the molecular formula is same. Molecular formula is same, but they have different structure. Its structure is linear. Its structure is branch. So such isomers, these are known as chain isomers. Such isomers are known as chain isomers. Second are the position isomers. Position isomers. Let's again write down the butane. I have written 1 chlorobutane. I have written 1 chlorobutane, and you can write another compound molecule like this. Let us see the molecular formula of both. How many carbons are there? 4 carbons are there. Hydrogen 3, 5, 7, 9, H, 9, Cl. In the second case, how many carbons are there? 4 hydrogens are there. 3, 3, 6, 7, 8, 9. 9 hydrogens are there, and 1 chloro is there. So in these both cases, the molecular formula is same, but structure is different. Structure, they are differing from each other in which respect? Here is the 1 chloro. Here is the 2 chloro. The position of the chloro group, it is varying. The position of chloro group, it is varying. Hence, such a kind of isomers, these are known as position isomers. Next type of the isomers are the functional isomers. Here, the example which is given, this belongs to the functional isomers. Here is the molecule formula is same, but the molecule have different functional group. Molecules have different functional group. You can write this molecule like this: CH3, CH, CH3, OH. This you can write CH3, O, CH2, CH3. So write down their molecular formula. How you can write their molecular formula? C3, H5, H is 7, H7, and you can write H8, 1 H is there, 3, 6, 7, 8, 8 H are there, and 1 oxygen is there. In the case of second case, the carbons are 3 and hydrogens are 3, 3, 6 to 8. Hydrogens are 8 and 1 oxygen is there. Here, this is the different molecule, this is the different molecule, these are different compounds. Here the functional group is alcoholic function group, here the functional group is ether. So these are totally different from each other. So such isomers are known as, which are varying from each other in the terms of functional group, these are known as functional isomers. Next type of the isomers, these are known as metamers. In the case of metamers, they vary from each other in the terms of number of carbons on either side of the functional group. On the either side of the functional group. So here we can see that both are the ether. Both are the ether. But in the case of around oxygen, on one side there is a methyl group and another side there is also a methyl group. In this case of the ether, on the one side there is the methyl group and another side is the there is propyl group. So they are differing from each other in the terms of alkyl group, number of carbons. In first case, two carbons are on both sides. In first case, one carbon is on one side, and in another case, another side, three carbons are there. So these type of isomers, these are known as metamers. Next are the tautomers. Tautomers are the ketoenol forms. These are ketoenol forms. It means there will be the ketone and there will be the enol. Methyl groups are on both sides. What happens here? This electronegativity of oxygen is higher. This pi bond is moved on the oxygen. It will bring the negative charge over the oxygen. And hydrogen as a positive charge species will leave this methyl group. And here this sigma bond migrate in the form of pi bond. And this oxygen will become negative charge. Hydrogen will leave this substrate as a positive charge species, and you will get alcoholic group. So this form where ketonic group is there, it is known as keto, and where the OH group along with the double bond is there, that is known as enol. This is known as ketoenol form, and ketoenol form is known as tautomerism. Both have the same molecular formula but different structure. Another type of the isomers, these are the ring chain isomers. You can say that you have this triangle in thermochemistry. You can say this is your cyclopropane. This is your cyclopropane. Here you can write propene, one propene and another is cyclopropane. Let us see their molecular formula. Propane, it means that there is CH2 bond CH2 bond CH2, this like this. So you have 3 carbons, molecular formula is 3 carbon and hydrogens are 6, H6. In this case, linear molecule is there, a cyclic molecule is there. In the case of linear, how many hydrogens are there? 3, 4, 5, 6. 6 hydrogens are there, 3 carbons are there. One molecule is cyclic and another molecule is linear. So such a type of isomerism, it is known as ring chain isomerism. In all cases, you can see that the connectivity is different. Connectivity is different. In the case, if you number this first carbon, second carbon, third carbon. First carbon is attached to hydrogen and second carbon is attached to 2 hydrogen and 2 carbons. Third one is also attached to 2 hydrogen and 2 carbons. In second case, here the first carbon it is attached to 2 hydrogen and 1 carbon. Second carbon it is attached to 2 carbon, 1 hydrogen. Third it is attached to 3 hydrogen and 1 carbon. So in both cases the connectivity that differ from each other. The connectivity differs from each other while molecular formula is same. So such isomers are known as structural isomers or constitutional isomers. I have told you that another case of the isomerism, it is your stereoisomer. It is your stereoisomer, and stereoisomers have same connectivity. These have same connectivity, and these isomers are further of 2 types based upon the funda that whether these compounds can be interconverted by rotation around carbon-carbon single bond, by rotation around carbon-carbon double bond. Where these compounds can be interconverted by rotation around carbon-carbon single bond. Let us see here 2 different types of isomers are with you. which have same connectivity. Let us see, you have these two compounds. This is known as cis compound, and if I write another compound where chloro group are on the opposite side of each other, then that form it is known as a trans form. When these are on the opposite sides, this is trans form. When these are on the same side, this is the cis form. In the case of stereoisomer, it is a form of stereoisomerism, and if we see in this case the connectivity, this is the first carbon, this is one is second carbon. First carbon it is attached to one chloro, one hydrogen with double bond to carbon. In second case, first carbon it is attached to one chloro, one hydrogen, double bond to another carbon. Second one similarly it is attached to one chloro, one hydrogen with double bond to next carbon. In the second case, trans case, this carbon is also attached to one chloro, one hydrogen with double bond to the next carbon. So in this case, the connectivity it remains same. The connectivity remains same, and such isomers, these are known as stereoisomers. These are known as stereoisomers, where the cis and trans form exist. These isomers are known as configurational isomers. These isomers are known as configurational isomers. Here, if the rotation around carbon-carbon single bond is possible, not possible, carbon double bond is not possible, it is restricted, then that configuration isomer is known as geometric isomers, and these are cis and trans. This one is the cis form, this one is the trans form. Here, trans form, this one is the cis form. And such isomers are known as geometric isomers. Here, first of all, in the case of stereoisomers, we have to see that this can be converted by rotation around carbon-carbon single bond. If yes, then these those are known as configurational isomers. If they are not converted by rotation around carbon-carbon single bond, they are known as configurational isomers. If these can be converted, those are known as conformational isomers. So here, if rotation is hindered, geometric isomers, cis and trans form. If rotation is not hindered, then those are known as optical isomers. These optical isomers are important for us. These optical isomers are important for us. In the case of optical isomers, as the name indicates, optical means related to the light. These optical isomers tend to rotate the plane of the plane polarized light. They tend to rotate the plane of plane polarized light, either towards left or towards right. And these isomers can be further divided into two types: anisomers and diastereomers. Anisomers and diastereomers. Anisomers are those compounds which are mirror images of each other. This is the important term here. Anisomers are those compounds which are mirror images of each other, which possess the handedness. These are the anisomers. We will explain them in detail. These anisomers, they possess the handedness. Handedness means this is my right hand and this is my left hand. If I move this left hand from here and put the mirror here, then whatever the image of my right hand, it is formed in the mirror, that will be image of my left hand. It means the compounds which possesses the mirror images of each other. Mirror images of each other are known as anisomers. And as you know that we cannot cut our right hand and fit this right hand over the left hand and cut the left hand over and fix this over the right hand. We cannot fit over each other. So this means these mirror images, that is my right hand and left hand, these are non-superimposable of each other. Non-superimposable of each other. Non-superimposable simply means these cannot be fitted over each other. These cannot be replaced each other. These are specific, these are unique, and nobody can replace them. Even the mirror images also. And another case is diastereomers. Diastereomers are the having same molecular formula, differ from each other in spatial arrangement of atoms and molecules. But these are not the mirror images of each other. Here you can see one carbon is there, another carbon is there. First carbon is attached to methyl, chloro, and hydrogen. Here first carbon methyl, hydrogen, chloro. Second carbon methyl, bromo, hydrogen. Second carbon, second case bromo. But these are different. These are not mirror images. If I put mirror at the center, this compound it will not be mirror image of each other. But they have same molecular formula. And such isomers which are not mirror images of each other, those are known as diastereomers. We have discussed in detail what the constitutional isomers. I have told you the constitutional isomers or structural isomers, same connectivity and different structures. Geometrical isomers, cis and transform, optical isomers, which possesses the handiness. Collectively, geometrical isomers and optical isomers are known as stereoisomers. I have given already during the classification different examples, different types of the isomers. Functional isomers differ from each other in the terms of functional group. Alcoholic functional group is there, ether functional group is there. Constitutional isomers and structural isomers, one and same thing we have discussed. And position isomers, I have told you, differ from each other in the terms of position. And isomers, I have told you, an isomer simply means the mirror images of each other, which are non-superimposable. Non-superimposable term means only which cannot be fitted over each other. And diastereomers, these are so now the question arises how you can represent the structure in 3 dimensions. Here, stereochemistry simply means the representation of any molecule in 3 dimensions. You have to represent the structure of any molecule in 2D, and structure must show its 3D appearance. I have already told you that if you have any compound like methane, the compound you have like methane, you can represent that compound with the help of flying wedge structure. This form it is known as flying wedge representation. This hydrogen, carbon, they lie. This carbon, hydrogen, carbon, they lie in one plane. One hydrogen is on you and another hydrogen is away from you. This is a 3-dimensional representation of simple molecule like the methane. Here, this is simple molecule. Let's take any completed molecule. Here carbon is there, which have 3 different groups. Different groups. Now, if you convert this, you have to convert this flying wedge structure into the Fisher's projection. You have to convert this flying wedge structure into Fisher's structure. This is 3-dimensional representation. If you have to convert it into Fisher's structure, what you have to do? You have to think that this molecule like horse, these two parts, hydrogen, carbon, hydrogen, these are in one plane. These are in one plane. These are in one plane. So these two are in one plane. Suppose this is horse-like structure, or this is just like horse. This is the mouth of horse, and this is a tail. This is the one ear toward the left side, and another ear toward the right side. It is right side, it is left side. Hold left side ear of that horse and convert like this. Left toward this, right toward this. It means that what you can say here, you have holded the left-handed ear. That is, this group is bromo. Bromo, it will come to this position, while OH will come to this position. And this mouth and tail along with carbon, mouth will remain on upper side, mouth is our methyl group, and tail is our hydrogen. So you can convert this flyweight structure into Fisher's projection. You can convert flyweight structure into Fisher's model. The flyweight is a three-dimensional representation. This also is a three-dimensional representation. Here, the bond which lies horizontally means these bonds are pointing towards you. You can write this structure like this. The bond which lies horizontally, these bonds are pointing towards you. It means bromo and OH, these are pointing towards you. While CH3 and H are pointing away from you. This is also three-dimensional representation of the structure. I have already told you how to convert the structure into interconvert. Flyweight form is there. This is the right mouth of the horse, right ear of the horse. This is the left ear of the horse. Hold these two. This will become horizontal. OH will come to this position, and H will come toward this position. Ear will become like this, right and left. At vertical position, it will be the mouth of the horse, COH, and downwards methyl group, it is the tail of the horse. So this is the Fisher form. And again, you can convert, you can try this molecule, find you can convert this flyweight form into the Fisher form. And the rest form, this form is known as ball and stick model. This is known as ball and stick model. I have already told you about the ball and stick model while discussing about the geometry of the methane. So what is the biological importance of these molecules? You can convert this molecule into flyweight. This is Fisher projection. What is the biological importance of these two molecules? So here you can see that one compound where the carbon is at center, this group is different, this group is different, this group is different, this group is different. I have told you methane can hold the 4 atoms. Here the 4 hydrogens are there. If 4 hydrogens are there, all the 4 will be same. All the 4 will be same. If all the groups are different, then what will happen? What will happen? In biological system, it has been found that this molecule, it acts as substrate, while this it will act as the enzyme. Here, this molecule is the mirror image of this. If you put the mirror, this molecule is there. If you put here mirror, its image will be formed here. Its image will be formed here. If you see that enzymes are same. Enzymes are same. First is your scale is there, triangle is there, circle is there. In this case, enzyme is same. Scale is there, triangle is there, circle is there. In the first case, this ball will fit in circle, triangle will fit in circle, this scale will be fit in this scale. But its mirror image, this one is its mirror image, it will not fit. Here ball will not fit in scale. Here triangle will not fit here. Here scale will not fit in the circle. So that's why I already told you that doctor recommend you nowadays leocitrazine, not citrazine, because citrazine it contains the 50% dextrorotatory compound and 50% leocitrazine compound. This leocitrazine anti-allergic, it works for you, while this dextrorotatory citrazine, it will cause the sedative effect. It will induce the sleepy. Doctor will recommend you while driving, do not take the, after taking the citrazine, you have not to drive because you can feel the sleeping effect. But nowadays we are capable to separate the leocitrazine from the dextrocitrazine. So if you have taken the leocitrazine, that has only anti-allergic effect, that will work. What is the problem with you? So in biological system, mirror images of each other, compounds which are just mirror images of each other have different effect. It means we cannot replace our left hand with the right hand because these are both the